Okay, so it's me, Joe Burnett. I'm here with Touni, and we are going to talk about Step Runner in Kubernetes. We're going to kind of go through what um, what does it look like to actually run steps? Like, how does this model change? So I'm going to draw a picture. I'm going to start with a node. I'm going to add a runner manager and a pod. And these could be different nodes, or they could be the same node. It doesn't really like make a difference. You know, so this is the runner manager. And what happens is when GitLab has a job, the runner manager pulls that job. And that job is going to include steps, right? The change of model from what we did before is instead of pulling down a script and then jumping into the pod over here, it's for the job. Instead of either running the pod with the script or starting a shell and then connecting to it, we're actually going to start step runner. So when we connect to this pod, we're going to have inject step runner into the image, and it's going to start a service on a local socket, right? So maybe like temp, step runner socket. So there's going to be a gRPC service running here.
Okay.
And that service has things like run, and you give it a payload, or um, watch the logs, etc.
Okay.
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 So this pod will start up. It'll be ready to run jobs. And so uh, the runner manager will go through the Kubernetes API to run exec.
Yeah.
So it uses the Kubernetes API for auth,
Mhm.
which comes down to being an auth API on the node, which then hops into the pod. And what it will exec is it'll bootstrap a connection into that gRPC. So then you'll have this, you know, a client inside the runner manager that is connected to step runner. Okay.
Okay.
So now it can issue this run request. And if it gets disconnected, or if there's any kind of a problem, like maybe the runner manager pod is disrupted and it gets moved to another node or something.
Mhm.
Um, all it has to do is run that same exec to get a new connection
Okay.
and run list to find the jobs that are running on that pod.
Okay.
So actually, when you run, if you also include some metadata, such as the job CI token or whatever it is that runner manager needs to know, this also allows runner manager to backfill its state and continue to stream logs. So this also
Okay.
gives you the same
Fault
resilience.
tolerance.
What's that?
Fault tolerance, as it's called for the ML that we are working on right now.
Yeah. Yeah.
Okay.
Yeah. So runner man or step runner actually implements this feature, but it works this way for all the executors. So like even the Docker executor, even like the Docker autoscaler and instance executor, they all connect, they all just get step runner running in the environment as the agent, right?
Mhm.
And then connect to this gRPC. And so it always works the same way. So like the code that's inside of the runner manager, there's going to be a little bit of specific code to the uh, executor for how to connect, right?
Mhm.
Kubernetes needs to know like to connect to the Kubernetes API. But once it's established that connection, then it's a common code path.
Okay.
Okay. So services.
Uh,
Uh,
before before we
what?
move to service, I have one. Sorry, I have one question.
Mm-hmm.
Uh, do we have the same pod for multiple jobs, or one part of a Kubernetes executor as it exists? The creation of a pod spec and all these things will still be there. Because right now, the way I see it is the Kubernetes executor kind of creates a pod per job.
Yeah.
to have everything run.
That
Does
doesn't
the same
change.
context?
That doesn't
Okay,
change automatically with Step Runner.
okay.
Because there's in the context of running a job, there's multiple phases, right? There's like
Mhm,
creating the environment, and
mhm,
then there's connecting to the environment, and then actually running the job. So the
mhm.
executor still specializes in creating the environment.
Okay, okay.
The executor also, or the Kubernetes executor
Yes.
does
Mhm.
specific. It also specializes in connecting, and then the running will be common.
Okay, okay,
For other executors like Docker Autoscaler and instance executors, it's actually fleeting that specializes in creating the environment,
okay.
right? So it's pluggable. So
Mhm.
that actually means the runner manager code will be the same. So we've abstracted that part out too. And I would like to do that with Kubernetes at some point, but it's still it's an orthogonal concern. So
Okay,
we don't need to change that
okay,
part yet.
okay,
And also fleeting abstracts out the connection part because there's like this generic connection info. You get SSH info, right?
mhm, okay,
Um, so for now, that part of the Kubernetes executor will stay the same. But when you talk about like what happens inside is we'll actually be having this agent inside. So right currently we do have an agent that is sometimes kind of close around by the job, which is the helper, right?
yes.
Currently the helper, we started in another container and
Mhm,
it shares a file system, does helper stuff, downloading artifacts, downloading the Git repo, etc., and then kind of is put to the side, and then the job runs in the job container, and um, just has the file system, so it's all that stuff is set up. We're going to start by moving the helper into the job image for dynamic secret masking, and then it'll actually be the step runner that gets moved into the job image.
mhm.
Um, and so the whole thing will be actually done directly from the job image.
Okay, so we won't have a helper container anymore. That's correct.
Maybe.
Okay,
I think it'll be, like we'll slowly like reduce the things that we use the helper
okay,
for. And there may be a special case where there's some things we need to bring with us. Like Git is a little tricky because um, uh, uh, the various distributions of Git also depend on like what version of the C library you use,
yeah,
etc. So we're just going to take it one step at a time. But the end objective is to get the step runner inside, so we just drive the job from there.
okay.
Yeah, can I talk to you about services?
Yeah, go ahead. Thank you.
How does services for a Kubernetes pod? Do you just create additional containers in the pod? Is that right?
Exactly. Yeah.
Yeah. Okay. So the way that it works so that's actually pretty easy. I love Kubernetes, but I mean that's just straightforward, right? Like you just make the services and then it all starts.
Mhm.
So you already kind of what you need to know for step runner for Kubernetes, but I want to give you one kind of additional piece of context for like how services work in the instance executor
Okay.
or even in
Docker.
Docker, like how so let's say that we have a VM, right? And we have GitLab runner manager here. Same deal. It's got a little client. There's going to
Mhm.
be step runner running inside the VM. So this looks a little bit different than what we have right now. What GitLab runner manager will do is it'll connect to this step runner and it will say, please run these steps. And one of those
Okay.
steps is going to be to create the services. So there's going to be the Docker API will be running on this VM, right?
Mhm.
So it'll create the network. Then it will start the services. So you're going to have, these service containers here, right?
Mhm.
And then it will also start the actual job container. And inside that job container will be
Another step.
Step runner two,
Okay.
little baby step runner. And so step runner is designed to be sort of recursive in this way, so that and support natively like very seamless delegation. So what step runner will do, there'll be a run call here, and that run call will be like, set up services and then run the job, right?
Mhm.
And so this first run call will deliver this payload and it will do these things. And then this run a job one, right, will actually go into this second run call, right?
Okay.
And so then all the steps of the job will actually get
It's
given to
run
this
there.
step.
Okay.
And one of the nice things about this is also the results all come back out. So like it all kind of comes back out into a set of structured results that show you exactly what happened. So
Okay.
like even the results, the structured results from inside the job container get stitched into the tree of the higher level run request.
Okay.
So what GitLab Runner Manager gets back is exactly what happened, even for setting up services, et cetera. So you can see what was the exit code for setting up this service and what was the
Mhm.
error, et cetera.
Okay.
Um, yeah, so this is kind of how it's going to work with Kubernetes. Actually, Kubernetes does this orchestration, right? That's the
Mhm.
value of Kubernetes is it does that for you. Um, so yeah, got any questions?
Yeah. And right now, how do you manage the entry point of each the job container, service container with Docker? Let's say that I have a GitLab CI YAML,
Mm-hmm. Mm-hmm.
and okay, the easy case. I set my entry point. I think it's called command. No, it's called entry point and command. I set my entry point and command in the service,
Mm-hmm.
and for the job, I just provide an image. What will be that's the simple case. I don't want to bypass the. I don't want to overwrite. How do I say it? I don't want to honor the entry point. I will just use the Kubernetes word to keep it easier for myself. So how will it work?
Okay,
I have an image,
that's a great
I
question.
have services. Yeah.
Yeah, yeah. And this that's actually I'm glad you asked that question because that's actually why I wanted to talk about this. I wanted to
Yeah.
get us down to this point because this is the relevant part for the discussion you and I were just having about Kubernetes entry points. Uh,
Yes.
this right here, right, is a step. And what that step says is run these steps in this container. So
Mhm.
like we will have a step that is, for example, so I'm going to kind of put this in the YAML
Okay.
language that we sort of see in CI. It'll probably be compiled into like a more simple proto, but we'll just do this because it's easier to read and they're kind of orthogonal. So you can say name, run in container, right?
Okay.
And the step will be gitlab.com/GitLab steps. I don't know. I don't know what it'll be called. It'll be called, run me. We will own
Okay.
a step that is this logic and it'll be released separately too, right? And we'll have
Mhm.
version one.
Okay.
And one of the inputs will be the steps to run. So this is going to be the actual job right here.
Mhm.
Okay. So that's this little part here where we say like when we run that step
Mhm.
here, it's going to create the Docker container by calling the Docker API, right? That's what
Mhm.
this step does. And then it will bootstrap a step runner inside, and then it will connect to that step runner, and then it will run these steps. So that's
Mhm.
that's this whole like process here is encapsulated in this step. Well, when you run the Docker container, you can choose what to do, right?
Mhm.
Like for example, we could have other inputs such as um, entry point override. and
Okay.
you could specify an entry point to use.
Okay.
All right. Or you could instead of an entry point override, you could just say, um, well, here's the funny thing. Like in the use case that you were telling me, where a user wants to just run the container and not even use script, like
Mhm.
script is already built into the container and they just want to
Mhm.
use CI to run the container, you won't have a job payload, right?
Yeah.
Like that's the
You
whole
just
point.
have the
Is
image. Yeah.
we don't want you to give them a payload. So you could actually um, just omit this part, right?
Okay.
And then it would just start the container. And you could just or like so what I'm saying is we can actually make whatever inputs we want here.
Okay.
So you're gonna have this you're gonna have in CI, you're gonna have some expression which says job, uh, you know, run this thing. Like here's an image, right, that the
Mhm.
user specifies, and you're gonna say run these steps.
Mhm.
And right now we're using environment variables, which is a little bit weird, but whatever. It doesn't really matter what the interface is. But you can come you when you provide. Let's say we have something like uh, if you don't specify run and instead you say I don't know. Let's call it default entry point true. Now, what this is called and how we want users to express this kind of a require like this kind of a model is kind of up to pipeline authoring, right? Like it really should be pipeline authoring to tell us what the user's intent is. And when this job here gets compiled, right, it'll actually get piled into um, protobuf, which is actually also called the baseline model. And what that will do is that's this thing that actually runs here, right? So like this is all compiled from the user's intent. So we have this little compile.go, and I'll give you a link to this file. And it reads the steps, right? And it outputs this proto. And so what it will output, it will write this. Like this here
Mhm.
is what it will output over here. So
Okay.
it'll just say, okay, you want to use the default entry point, fine. I know how to make that happen with this step that
Okay.
specializes. Does that
Okay.
make sense?
Yeah. But I asked the question for this reason because before, and I was asking if the executor will still be in charge of creating the environment. I mean,
Oh,
if we will have one job per one pod per job.
mhm.
If if the executor is still handling this part, that means that uh, because we need to create the job before actually com communicating with the step runner within the pod. So
Mhm.
that means all the entry points should still be managed
Oh, because
in the Kubernetes
the entry points are
executor.
part of this pod spec.
Yeah,
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 yeah, yeah. Well, that's a good question. Like what? Hmm. Yeah, I haven't figured that part out yet. We should that would be an interesting part to figure out.
because one of the things I think that would be that I like with it is as we have another YAML we are providing, we
Yeah.
can handle it a different way. And it's not a breaking change, it's a new way. Maybe I'm just oversimplifying everything, but let's say we have the default entry point true. So when creating the job, if we have default entry point set for the job itself and for the services, we automatically know that we don't touch anything. If not, we just replace whatever has been provided so
Yeah.
that when we create the pod, everything is there. and then
Mhm.
the step jump into, I don't know, I'm thinking out loud, I don't
Yeah,
know
because it's
exactly.
what we get from what we get from GitLab is a set of steps to run as
Mhm.
well as a list of services. So
Yeah,
GitLab runner's job is to adapt that to a pure steps model by
okay.
um, taking those services and generating uh, it may be encapsulating. So actually, like what I was saying here with the compile.go, it might be actually not so much that this part is compiled from a YAML file, but maybe GitLab runner is responsible for taking this compiled payload and then
Mhm.
wrapping it in some steps that do the service setup. Or in the case of Kubernetes, not, right?
Okay.
Maybe it just becomes two different things. Hmm. Yeah.
For sure. Yeah, what? Nah, it will just make it overcomplicated for nothing.
Wait, what are you
Because,
thinking?
yeah, I mean, it's a wild idea. I even don't think I should say it, but I will say it
Say it,
anyway.
say it.
What will make it kind of fall back on the Docker instance and Docker way will be if inside of a pod we kind of create containers, so it's kind of Docker and Docker, and it make the whole thing
Mm.
complicated for nothing.
Yeah, it's
Yeah,
funny
so
because we have kind of created like a weird contorted version of Kubernetes here, right? In
yeah,
running, where we make kind of VMs and we kind of put pods containers in there that are associated with other containers that have the same life cycle, right?
yes,
So like have you seen that XKCD where like inevitably you reproduce Kubernetes? I think anyway, we're just reinventing Kubernetes, but we're doing it in very like we've kind of evolved it. So like we're gonna also need to evolve these abstractions for
yeah,
the space. But yeah, I don't know. Like I feel like I'm open to finding ways to adapt our interfaces to work for both. Like, for example, the idea of having a fleeting plugin
mhm,
that also provides a hook for you to do post job customization. So, right now,
okay,
fleeting, it gives you just a list of VMs that are all the same. Uh,
okay,
what I would like to be able to have there be a before the job phase and an after the job phase, and you can have all this or
okay,
right a little bit of both.
okay,
In the case of Kubernetes, all of you can't even create the environment until you have the job in your hand, right?
yeah,
You don't know what the resource requests should be,
mhm,
so it's all post job customization. Um,
yes,
And uh, so if we were able to extend the fleeting API to let you do that, then actually all the code from the Kubernetes executor could actually be put into the Kubernetes plugin.
okay, I see.
So like you could take a Kubernetes plugin, plug it into Task Scaler, you get a job, it
Mhm,
says, okay, I'm ready for, some capacity, and here's the job that it's for. And then the Kubernetes plugin can turn that into a pod request,
mhm,
create it, give you the connection info back.
and then,
This side
yeah,
of it doesn't even need to know that it's Kubernetes, right?
mhm, yes,
And this also works for the custom executor too. Like the custom executor has a lot of like pre-job hooks, which is what a
okay,
lot of the users use it for. Like um, for high performance computing, a lot of times, or on big clusters, you need to know the name of the user that's running the job before you can ask for the capacity.
okay,
Right? So, like again, you have to have the job in order to do it. So, anyway, that's kind of I'm just looking to see if that fits as we move along. But for
okay,
now, we keep the Kubernetes executor, right? Because it's entirely in a different phase from the other ones, and And yeah, you're gonna need to have the job there to know what the entry points are, and probably just like yeah, probably you won't probably with Kubernetes you won't use Step Runner to set up the services. You'll use
Mm,
Kubernetes to set up the services, right? You'll
yeah.
just so with Kubernetes, you're only going to have that one hop into the job container
Mhm.
to drive it. So
So
anyway, cool.
in that case, then, as the Kubernetes executor is at least for now, will still be in charge of handling the environment setup,
Yeah,
and as the existing feature flag is kind of hard to change without breaking
yeah.
eventually, because that is,
So
I mean,
this does Step
it's
Runner
it's
doesn't
not
really
a,
change the service
yeah,
part. Yeah,
exactly.
Step Runner doesn't change the service part at all. Actually, you know what? Step Runner doesn't really even come into play here at all
Yeah,
because like all of the entry points are before we touch the
the
first.
creation, exactly.
Yeah, yeah.
So
But
should
you know
we?
what? Is it does give us if we can have a common language for what the user wants to do, like
Mhm.
just run my container, don't
Yeah,
have any entry point, we can make sure that we do that with Docker in the same way that we do with
so,
Kubernetes. So like
exact,
you should be able to just seamlessly take your container across both and not
e-
know the difference.
exactly. And
Mm,
that's why, I mean, if we had something like default, it was just an example, but default entry point at set to true,
yeah.
that would mean for Docker, for Kubernetes, when you are creating the pod spec, don't change anything. Just leave it as it is, and it will take care of itself.
We had remember when we were talking about Kubernetes config, there was the idea to use
Mhm,
steps to set up the environment.
mhm.
That might be one way to get like if you can get a common code path for environment setup. I don't know. Kubernetes is so different though. Like it's a whole different thing. Like it's it's not run these commands to talk to Docker. It's just create this YAML. So
Exactly.
we'll see. We'll see. We'll just start with nothing changing other than when it comes time to run the job. Instead of
Mhm.
execing a shell, you just exec a bridge to the gRPC and then run steps.
Yeah, you remind me my another question I had. So basically, that would mean the exec and the attach wouldn't be anymore, because we would just, the
Yeah, you don't
pod
need
is
them.
existing, we connect
Yep.
through gRPC, we execute, and
Yep.
then we stream back the log we are receiving from the pod,
Yep.
from the
It's a
job pod.
more it's a more generalized version of the attach, right?
Okay.
Like it does the
Okay,
same. It's
perfect.
the same strategy as attach,
Perfect.
like having an independent process that you can reconnect to.
Perfect.
But the nice thing is you won't have to multiplex control signals in the
Mhm.
logs because it's a gRPC. You have a separate API for streaming logs and a separate API for like knowing when the job is done, etc.
Okay.
So it kind of makes it
And
easier.
can I ask the last question?
Hit me.
Yeah, okay. So right now there
You
is
don't promise it's the last question though. You don't know that.
last until it's not. Um, we have, at least I have an issue. I keep coming back to it time to time to see if there's new thing I can use to actually solve this issue. The PID1 handling on the job pod container, on the whatever container in the job pod,
Is it
it's
still in the
kind of,
Kubernetes space?
yeah, it's kind of weird, because sometimes the PID kind of catch the signal and kill everything, and sometimes it just doesn't. So the pods stay in terminating phase until eventually Kubernetes kill it once and for all.
Mm-hmm.
So for all the investigation I could make so far, what I've noticed is, as we have a detect shell script, which is then actually changed by the actual terminal, I mean the actual shell which is running on the pod, it's where the kind of signal propagation kind of breaks somewhere there, because we have a PID1 which is then replaced by the actual shell which is running on the pod. So
Mm.
whatever, even with them init installed on the pod, it still sometimes fail to gracefully shut down everything.
Hmm.
So my question is, with step runner, as we have now the step runner service running inside the job container,
Hmm.
shouldn't it make it easier to handle this part? Because we send the gRPC command, he will see, okay, I start those process, I just kill them one after another, and I
Yeah,
quit myself.
I think that was the hope. That was part of our hope with Step Runner with this model is all the whole process tree should hang off of Step Runner, right?
Perfect. Okay.
Um, maybe there's something special we need to do, which is like before you exit, if there's any process running that's not one of your children, kill it.
Mhm. Okay.
So that could be like a step. There's a concept like a teardown step
Mhm.
in GitHub Actions, like if you say an after script or afterwards or something, um, it'll actually lift that up to the job level and run it like a job level defer statement. So you can run
Okay.
action one that has a after step, and
Okay.
then action two, which has an after step. But those don't actually happen yet. Once all the actions are done running, then it runs those afters in reverse order, just
Okay.
just like defer, right, in going. So we want to have something similar in steps because it's an important use case. For example, if you write a step that sets up secrets in the environment,
Mhm.
you want a hook to delete them on the way back out. So here we could actually um, have a step that runs, and its job is to run the actual steps,
Mhm.
and on the way back out, kill everything.
Yeah.
We could call it like, you know, uh scorched earth step, like just make sure everything's toast before you exit, right? So that
Okay.
if any
Perfect.
processes manage to escape our process tree
Mhm.
and are not going to exit, we can proactively clean those up. And we do this
Perfect.
in an ad hoc fashion already. I think in a few executors, like a shell executor, I think we already do a little bit of this, hunting around looking for
Mhm.
processes, but
Mhm.
it's executor specific, right? So we want to make it, if it's a step, then it'll just be one interface. It'll just
Mhm.
depend on operating system, not
Perfect.
executor. That's a good question.
That was actually my last question. So
All
I
right,
have no
awesome,
more.
awesome. Let's stop there. I'm gonna stop the recording, okay?
Okay.
If I can find the button.